Hello friends, welcome to my channel. Today we are going to learn about generative AI. We all know what is generative AI, but in depth, actually 90% of the people we do not know what generative AI is. We use it like Google search, we open ChatGPT, we put some commands, we ask some questions, we get some response back and that's it. But after today's video, we'll come to know these many topics. So if you complete this video today, you will come to know about generative AI, what it is actually. We'll explore generative AI using ChatGPT. We'll comprehend the prompt engineering. So we'll know what is prompt engineering, how to use it. Then we'll understand the API and API keys. And ultimately, we'll understand how to use generative AI programmatically. So without wasting any more time, let's start. What is generative AI? We all know ChatGPT. Yes, ChatGPT is generative AI, but it's not only ChatGPT. There are many such LLMs are there, which are all generative AI. So, as per the definition, generative artificial intelligence refers to system that can create new content. So that is the main core of this generative AI. There, artificial intelligence was there before as well, but it never used to create new content. It used to categorize. It used to give some predictions, that's it. But now with this generative AI, it creates new content which are like human created contents. And in this video, we'll come to know how it creates the content. So for now, such as text, images, music, code, or video, rather than just analyzing or categorizing existing data. So this is the difference. It differs from traditional AI, which mainly detects pattern and makes predictions, but actually producing original outputs that resembles human created work. So by definition, generative AI actually create new content. It may be text, it may be images, it may be video, it may be audio, but it basically creates a new content and human like content. So this is a basic definition of generative AI. Now, the components of generative AI. Generative AI is a field of artificial intelligence focused on creating new content like text, images, audio, and code. While the specific architecture of generative AI system can vary, the core components typically include. So these are the core components. What are these components? Number one, foundation models. Second one is training data. Third one is generative models. Now we'll go deep into each of these components to understand that how it works behind the scene. That is the core concepts which most of us do not know. Although we know ChatGPT, but we do not know how it works. So let's learn it. Foundation model. What it is? It says these are the brains of generative AI applications. They are large, deep learning models trained on massive, diverse datasets like text, images, audio, code, etc. This training allows them to learn the patterns, structures, and relationships within the data, which enables them to understand and generate new content across various domains. Large language models are a well known subset of foundation models trained specifically on text data to perform tasks like text generation, summarization, and translations. So, what it says that this is the foundation model is the base layer. So, we cannot build these foundation models, means not like everyone can build it. It's very huge. So only very specific companies who has the capacity and capabilities to build it, they have built these foundation models for years. And now we can leverage those already built in foundation models. And we can, instead of basically creating it from scratch, we can start using those pre-trained models and fine tune and can use it in our applications. So what are the foundation models? The examples is GPT-4. So ChatGPT use this foundation model GPT-4 for text creation. Del E and Stable Diffusion, these are the foundation models for image generation. Llama is an open source language, large language model. So this is another LLM. And Clip, it connects image with text. So these are the few, but now there are many more foundation models are coming. So this is the core of generative AI. I hope you understood this part. We'll move to the next one. The training data. Now we know about foundation models, right? Which is very huge. Who actually use the data to get trained? Now the second part is the data. To train foundation model, what we need a large set of data. So this training data can be text data, can be image data, can be audio, speech, or can be video, based on what kind of models we are using. So the quality and quantity of data are fundamental to the performance of a generative AI model. So ChatGPT has trained, means we have feeded, means obviously the company has feeded a huge billions and billions of data, so that it has so vast knowledge about the data, and now it can predict what to answer. So these are the training datas. Characteristics of good training data is a large scale, billions of examples to capture complexity. Diverse, it should be diverse. It's not like one same kind of data we'll give, but we will give different types of data like science, literature, everyday conversation, everything, so that it will have knowledge about everything. The data should be clean. It should not be like error prone or duplicate or irrelevant content, otherwise the response will be irrelevant. Ethical, it should not be like it should be copyright protected and privacy should be maintained. So training data is the foundation of models intelligence. So now we know foundation model, and then we are feeding the training data to the foundation model so it can get trained. We'll move on. Now the main core thing, the generative model. Now we have a training model, we have a data, but how to generate the new contents, or how this generative AI generate the new contents, this is inside this chapter, generative models. This is very interesting and I hope you like it. So these are few but very essential generative models. So first one, what we will learn is generative adversarial networks. So these are the four mainly: generative adversarial networks, variational autoencoders, transformers, and diffusion models. So first, let's learn about generative adversarial networks. So this GAN, generative adversarial networks, consist of two competing neural networks: a generator that creates synthetic data and a discriminator that tries to distinguish between real and fake data. So what happens, so if you see this image here, right, the training data, so now we have feeded so billions of training data. Right now with this training data, this model has a discriminator, or then so this discriminator is basically based on this training data. It can understand that what is what. Now when we feed the data input, then a generator actually generate image or anything, right? It may not be image or something, means whatever it is, but here let's think about it's an image. So human image, say like generator is generating an human image, and then based on the training data, this discriminator has the power to understand that this generated image is not a real image like whatever the samples we fed them. So it can figure out it's fake. The more it will train, it will be more accurate. So now when it's this figure it out, right, it's a fake, it sends it back to the generator. So okay, I caught you, it's a fake one, it's not accurate. So this generator again generate a little more better. And this is how this model works. I hope you understood this part. So more and more this discriminator will accurately uh, predict that it's not a real and fake, the more accurate data this generator will generate. So this is how this generative adversarial network works. We'll move on to the next one. So this is variational autoencoders. So variational autoencoders, how it works, it's basically use an encoder decoder architecture. The encoder compresses input data into a lower dimensional uh, latent space, and the decoder reconstruct the data from that space. This allows for the generation of new similar data by sampling from the latent space. So here, when the input comes, it's basically encoded and put it in the pool, and from that pool it's basically get that and then again try to decode it and try to create that actual output, similar output rather. So this is how this particular variational autoencoders work. So it's basically first encode it and then it's decode that input based on the samples it has in the pool. So it can go to the uh, whatever the input was, right, it can again decode it to that same kind of input, rather output. Okay, we'll move on to the next one. Transformers. This is interesting. This architecture is particularly effective for sequential data like text. So basically most of our LLMs are now using these transformers to generate text. So how it generate the text. So transformers use a self-attention mechanism to weigh the importance of different parts of input sequence, which helps them understand context and generate coherent output. So most large language, as I said, right, most large language models are using this transformer architecture. So here, right, so see this example. Where should I visit locally? Greenville. That's the input, and then these transformers actually checking this whole input and identifying that what exactly is needed, and based on that it's predicting, and then it's generating the output saying uh, Asheville, Charlotte. So all the names it's figure out, right, which is like local to Greenville. So it's checking whatever are the local locations are Greenville, and it's just kind of predicting based on these inputs which it's got. So this is how transformers work. So these are the different models, LLMs. So encoder based models are these are BART, Albert, TinyBART. Then decoder based models are GPT-1, GPT-2, GPT-3, and then encoder decoder based models are BART and T5, MT5. So this is another way to generate text. Then the diffusion model. Diffusion models basically image generation use diffusion models, or stable diffusion actually means not only stable diffusion but most of the uh, LLMs who generate images use this diffusion model. So these models work by slowly adding random noise to training data and then learning to reverse the process to reconstruct the original data by starting with random noise and running the denoising process. They can generate high quality novel data, particularly images. So say like we ask them to generate image of a dog, right? So it has all the trained data, right? It has thousands, maybe billions of dogs images, different dogs images. So what it does, it use those already fed images and it adds some noise. So this is the process. If you see below, it's add a noise and then it do the reverse of that, and then it try to reduce the noise and remove that, and by reversing that process it generates another image. So this is the image it's generate by using its trained data. So this is another interesting model, diffusion model, which LLM used to generate the images. Now the key differences between traditional AI and generative AI. So now at the end of this slide, we are we now know, right, the difference between traditional AI and generative AI. So basically traditional AI never used to create a new content, but generative AI creates a new content. So core function analysis classification. Now generative AI, it's creation and generation. Primary task discriminates between data points, makes predictions, and classifies information based on learned patterns. Here in generative AI, it creates new original content like text, image, code, and audio that did not previously exist. So this is the biggest difference. Output for traditional AI, a classification, prediction, or a value exactly means it could say that okay, it's a spam, it's not spam. We could give some inputs to traditional AI, it can tell us that okay, it's a spam, okay, it's not a spam. It can say okay, this is 75% accurate, like that. And now this generative AI, it's a novel content that is unique and often mimic human like creativity. So generative AI is nothing but generating a new maybe like text, image, audio, whatever it is, right, a new content rather. Methodology often uses rule-based systems. So traditional AI, they often uses rule-based systems, decision trees, or classic neural networks trained on labeled data sets. Now generative AI relies on deep learning models like transformers, generative adversarial networks, and diffusion model trained on vast, often unlabeled data sets. Creativity lacks creativity. So traditional AI lacks creativity. Obviously, it couldn't create a fresh new content, but generative AI, it creates a fresh new content, means which never existed before. So that's how it's mostly copyright safe. Examples of traditional AI like spam filters, which could tell us that okay, it's a spam, it's not a spam. Recommendation engine, fraud detection, image recognition. So earlier, if we could give a image to traditional AI, it could tell us okay, it's a animal's image. Okay, more specific, it's a cat. But now this generative AI, it basically creates new content again, and everywhere it's same, right? It creates new content. Data requirements can operate effectively with smaller, more structured, and often labeled data sets. So traditional AI, they never needed like a huge data sets, but generative AI, they are only relying on data. The more data we feed, more accurate it will be, the generative AI. So it requires massive, diverse, and often unstructured data sets to learn the complex patterns needed for creation. So I hope now you all have an idea about what generative AI is and how it generates the content. We'll move to the next slide. So this is generative AI tool stack. Just to know, right, who are the key players of generative AI. So key players are Microsoft, AWS, Google, and their Facebook is also there. So Microsoft holds ChatGPT for text generation. AWS has Bedrock for text generation. Google has Bard for text generation. Code generation. So it's not only generating text, but these days generative AI actually can write a whole program, means whole application it can write. And I have wrote it in 4 hours. I have completed a whole project where I asked generative AI to uh, transform a SQL project to Java project, and it did it in basically it created in few minutes, and then overall thing I completed in couple of hours, and then it was running in machine. So code generation. For Microsoft, we have GitHub Copilot, which is very popular these days. Then AWS has CodeWhisper, Google has CodeY. Image generation, there are Daily and Imagen. There are few others. I think Stable Diffusion is there. Mid Journey is there, but they are not from these three companies. Yeah, but those are very popular. Like Mid Journey is very popular. Uh, Generative AI for image generation. Model development and deployment, Azure ML, SageMaker, and Vertex AI. Base LLMs, so ChatGPT use GPT-4, Bedrock use Olympus, and Bard use Gemini. So these are the LLMs, like the models which we just learned, large language models. So these are the large language models behind the scene are there. We'll move to the next chapter. Uh, Use cases of ChatGPT. This is important. We only know that we can ask ChatGPT a question and it gives us some response back. But now let's see the real uses of ChatGPT. It's huge. The usage are huge, and not only this much, it can grow to many folds. So overall, textual, it can generate text, it can generate coding. If we ask ChatGPT to do code, it will do coding. Educational, you can ask educational details, it can deliver that. Marketing and SEO, it can create that. Customer service, yes, it can handle customer service request and generate response for that. We'll slowly learn those, how to do those. Those are through AI agents, which we can come up with customer service through uh, ChatGPT, means using ChatGPT rather, programmatically. Human resource, customer service and support, content creation, we can create content. Chatbots, we can create chatbots. Language translations, we can ask ChatGPT, means giving English and ask them to convert it into French, it will do that. And research and analysis. So these are few main major uses or use cases, but there are more and more. We'll move to the next chapter. So this is an example how we generally use at this point ChatGPT directly. So if we ask a question with a text that explain me blockchain, so a 12-year-old can understand this, whatever we have learned using those techniques and the data it has in it, means the sample data, it creates this new content for us and send us this response back. One more example, when we ask them to write a Java code with latest Java syntax, so it can generate a Java program like this, and it can generate program in any other languages. Next, very important topic, prompt engineering. So we learned about writing something to ChatGPT and it's giving us some response back, right? But will it always do that? No. We have to be very careful and very accurate to get very accurate response back from ChatGPT or any LLM models rather. So prompt engineering is very useful thing. It's a skill of writing instructions which AI will understand, and that's how it can be very accurate when it's create the new answers. Just an example, if I ask uh, ChatGPT or a genie, right? I want money. It can give me $1 coin. It can give me $10 check. It can give me anything, right? But if I specifically ask it, right, I want $100 in my wallet right now in $5 bill, it will give me like $100 in $5 bill. So that's how this prompt engineering works. So in next few chapters we'll learn about the details of prompt engineering, the different structure of prompt engineering, what are it contents and how it should be. So see, this is an example of prompt engineering. So what we say, we need to have this many features in prompt engineering. When we are asking something, we should have a context, we should have a task, we should have an instruction, we should clarify, and we should refine. But even if we don't do all of them, we should have a context and task and instruction. These three are very important. So here, if you see this example, the uh, prompt is ignore the previous prompt in this conversation. So it's asking that, okay, whatever we are discussing before than this, just ignore those previous prompts. Don't bring those context here. And now it's setting its context. You are an experienced content writer with high levels of expertise and authority within the tech industry. So it gave the context to ChatGPT. Then it says your task is to write content that will be published online on websites, social media, email newsletters, and in advertisements. So it says this task, right? So it the task is to write a content. So it clarifies what kind of content it needs to write. So that's how it's giving the task. Then it's giving the instructions. I'll provide you with a topic or series of topics, and you will come up with an engaging article outline for this topic. So it says instructions that, okay, next I'll give you a topic and you give me all the details on the topic. And then it's clarifying, saying that, do you understand? And then it's refine, saying the another thing, right? What is it need to do? Rewrite using more natural expressive language and include some examples to accompany this information. So these are basically the important things should be having in a prompt engineering or in a prompt whenever we write the prompt to ChatGPT or rather any LLM. Now the other things apart from what we saw, the roles, there are three roles for a means in prompt engineering. What are these three roles? The roles are like user role, assistant role, and system role. User role is nothing but us. We are the user, means who is typing or giving the input, they are the user. Assistant is ChatGPT itself is the assistant, and then system is this LLM is the system. So let's see how it works together. In prompt engineering, especially when working with models like ChatGPT or other large language models that use a conversational structure, the roles of system, assistant, and user are fundamentals. They are not just labels, they define the perspective and purpose of each part of the conversation, which is crucial for shaping the model's behavior and the quality of the outputs. So now we'll see how they are different and how they work. The user. The user is the human or external agent that initiates the conversation and provides the primary instructions or queries. This is the role you as a human interacting with the AI primarily occupy. So this is basically us who writes means so let's see the example to be more clear on it. So we are typing to the chat GPT, write a short professional email to a client. So this role is user role, means user is asking chat GPT or generative AI to write a professional email. What are the main difference between Python and Java? Translate the following sentence into Spanish. So these are the user role, means these are asked by someone outside of this LLM. Next, assistant role. The assistant is the AI model itself. So assistant is nothing but that the AI model. Its role is to respond to the user's prompt and fulfill the given task. In a multi-turn conversation, the assistant's previous response become part of the context of the future interactions. To generate the output, answer questions and perform tasks is instructed by the user and guided by the system. So that's the purpose of the assistant role. Example, in response to the email prompt, subject. So we asked, right, to write a professional email. So the response is subject, follow up on project X, dear client name. I hope this email finds you well. So this response is coming from that assistant role. As we said, right, the assistant is nothing but the model itself. To the second question, right, Python is, means we asked what is the difference between Java and Python. So the assistant role has responded back saying Python is known for its simplicity and readability and blah 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 blah. So the AI model itself is playing the role of assistant. Third one, then what is the system role? It's quite bit kind of similar to assistant role, but it is not. How? The system role is the most powerful and often the least visible to a casual user. Yeah, we cannot see it directly, but it is there. It is used to set the global rules, persona, and context for the entire conversation. It's like an overarching director who gives the AI a set of instructions before the user even starts talking. Purpose: to set the stage, define the AI's persona, establish constraints, and provide instructions that guide the assistant's behavior throughout the conversation. This is where you can jailbreak or prime the model. Example, system prompt. You are a helpful and friendly travel agent. Your goal is to provide detailed and insightful travel recommendations. Always ask for the user's budget and interest before making a suggestion. So this is kind of a system role where we can give this role to AI itself beforehand. Before we start the real conversation, we can set the user role by typing something like this, saying that, okay, you are the travel agent. So this is your role now, and respond like a travel agent going forward for all my questions. So another one, right? If you see this, uh, you are an expert Python programmer. Only provide code examples and do not explain the code in and 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 do not explain the code in natural language. If you cannot provide code, respond with not applicable. So it says you are a Python. So it's setting that system role that you are a Python programmer. Now you will, whatever I'll be asking, you have to provide me examples, Python code examples for those questions. So this is the third role, system role. Now, if you see in examples, this is how it sets system role. Purpose: sets the overarching rules, persona, and context. So basically, the overall context it's setting the system, and how it's setting, we can write like this: you are an expert on ancient Roman history. Respond only with historical facts from that period. So this is how we can set the system role to the AI. And then user, we already know, right? User is nothing but whoever is asking the question. Provides the instruction questions and data for current turn in the conversation, like tell me about Roman Republic. This is user, and then assistant, it generates the response. Assistant is nothing but the AI model itself, right, who generate the response. So assistant has generated the response based on the system role it has. The Roman Republic was the period of ancient Roman civilization, beginning with the overthrow of the Roman monarchy. So this is very clear. I hope it is clear for you. For me, it's very clear, because we know first we are setting the system behavior by giving the context, then the user, which are us, who are asking the questions, and then the assistant, who use the system role and then generates the response back to the user. Okay, next chapter. This is very important. This is API. API is nothing but application programming interface. So we now know about ChatGPT, but this is not the only use of ChatGPT, just asking questions. But we can do so many things. We can ask questions based on the response. We can do some other activity, right? And we cannot do that in that ChatGPT screen. So we have to use ChatGPT or any large language models or AI models through programmatically. Now, how we do that through programmatically? Then we have to do it through application programming interface. It means we have to use the application programming interface. So let's learn what application programming interface is. An API acts as a communication bridge between two software applications and a separate service, which is the which in this case is an AI model. Okay, now let's give an example. This example is very good example to understand how it works. So say uh, we are the person, right, who sends a request to the waiter. Means we are in a restaurant, we need a food will come from the kitchen, right? But how we will connect to the kitchen? We can connect to the kitchen through the waiter, and that waiter is the API here. So we give our informations, means the request. It may be a text prompt or image or maybe code, whatever it is, right? And then that waiter takes it to the kitchen. Kitchen is basically the AI model where the response is getting processed, right? In kitchen, the food is getting processed. So that kitchen is the AI model where the response is getting processed. And when the response means get processed, then the waiter brings it back to us. So that's also the job of API, to bring the response back. So how it does that? API basically takes the response and return us in a format which we understand, right? So like a food, or here in programmatically like a JSON. If you already know how to do the programming, then you must know about JSON. So what we are doing is basically through a API programming, we can pass a request, which is a payload, to the Gen AI or Chat GPT or OpenAI, whatever you call it, or AI model. Then AI model will send us a response just similar to whatever we are seeing on the screen. ChatGPT is returning back, but it will then return back through a API in a JSON format, and then we can use it programmatically. Then based on that response, we can take a decision what to do. By using an AI API, a developer can access complex functionalities such as generating human-like text from a prompt, translating languages, or recognizing objects in an image with just a few lines of code. This saves an immense amount of time and resources, as they don't have to train their own massive AI. Yeah, so we don't need to build our own AI. We can leverage the existing AI just by using their API. So most of the large language model have their APIs, and we can use them programmatically. So we'll now learn how to use them programmatically. API key. To use a API programmatically, or to use a say large language model, right, or LLM model, programmatically through API. We need a API key. So API key is the secret code which is identifying that who are we, so that no one else can pretend like us and try to mimic what we want, right? So that they provide an API key. So what this API key is? The API key is a unique secret code that serves as a password or a digital ID badge for your application when it makes request to an API. So when we think that we will be using say OpenAI or ChatGPT, right? We have to go to the ChatGPT, we have to register ourselves, say with our email ID and password, and then we have to create an API key. So if you see this screen below, there's this image. This is where we have generated the API key. So that API key will be stored for us against that email ID, and we can download that API key, and then when we'll be calling that uh, LLM or ChatGPT or OpenAI, we have to pass that API key as a payload, and then that API key will authenticate your identity. The API key provides that your application is a legitimate user and not a malicious actor. So that API, through that API key, they will identify that okay, we are authentic. It will also authorize access. Say there are 5 features of that API which we are not enable for. We only enable say 3 out of 5 features. So that API key also decide that okay, those 2 features are not for us. We cannot access them. We only can access 3 features. Then usage track. Say we are only allowed to ask 100 questions per day, not more than that. So that API key is also track that okay, now you have done 100 questions already for today. Next question when we'll do, there will be a response coming back that your quota is covered, you cannot do any more question today. So that will again handled by the API key. And then enhanced security, obviously it can provide it can stop unauthorized access. So until unless someone is trying a different API key, it will block it. Means it has to be the exactly API key which we have created for us. So this is the API key which is very essential to use the APIs. Now we'll see as simple programming, how we can use API key and the API to get a response back from ChatGPT programmatically. In our next video, I'll do, means I write the code to exactly show you how we can write this programmatically and use it as an example, and how we can fetch the response back from ChatGPT or OpenAI rather. So using generative AI programmatically. Using OpenAI programmatically means interacting with their AI models via their API program interface, means application programming interface API, instead of through their web interface. This allows you to integrate their powerful models into your own application scripts and workflows. So instead of, as I said already, right, instead of using their web interface, now we want to happen it behind the scene. We don't want to open a chat GPT screen in our browser and ask the questions. We will be doing behind the scene programmatically. So this is the example where we are going to means where we'll see in a moment how it can be done. The most common way to do this is with the official OpenAI client libraries, which are available for several programming languages like Spring AI, Python, Node.js, and others. Let's see step by step how it can be done with Spring AI. So this example is with Spring AI. So if you know Java, you already can understand this. So it's very simple. We are using a Maven project. So this is a dependency. Spring AI, OpenAI, Spring Boot Starter. So this dependency is from OpenAI. It says, okay, this is our library. Use it to connect us. So this is the dependency we have added in the POM. Then in application YML, we have added that API key. This is the API key, OpenAI API key. So whatever we have created in OpenAI, that key we have to save in our machine, and then that key value we have to paste here as a API key. And this is the code. This is the say this is one service, a OpenAI service. What it is doing is it's basically using these libraries which this is the library, right? Artifact add, if you see what Spring framework AI .ai. So this dependency we have used here. If you see here, the first import statement, OpenAI chat client. So this is coming from this library, and second one is also coming from that library, AI chat model chat response. Sorry, this is not from OpenAI. Is the second import. Second import is coming from Spring AI. The first one is coming from OpenAI library, that chat client. So now we have created a chat client, and then this method, we are passing a prompt, which will be passing programmatically a prompt. It can be any question, and then it will call the chat client, and this chat client.call will call that OpenAI, and then it will get a response back. And then this response, from the response is it's coming in a JSON format. Then we are getting the content out of that JSON, and then we are returning it back from this method. So how we can call that method? So this is a REST controller in Spring, where we have used that service, the service we just saw in previous slide. And then we are calling this chat method. This chat method is calling that service.ask, and we are passing that prompt, and then it is returning the response back here. Now how we can test it? So we can test it through many ways, right? Rather, I'll test it through Postman when I'll do the programming. So we are calling, so this program is running in my local Tomcat in 8080 port, and I'm calling that endpoint chat, and that prompt I'm passing this information: explain blockchain like I am 12. So this is the prompt I'm passing, and then the response will be like this: blockchain is like a digital notebook that everyone shares, blah 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 blah. So this is how programmatically we can use OpenAI or any LLM and generative AI rather. uh, Means this is the bigger world actually. Not only typing in that chat GPT and get some response, but this is the bigger world for the programmers who will be doing the programming. So in future videos we'll be moving towards that. We'll be doing programming slowly, and we'll see how it can be done, and we'll be generating different AI agents programmatically, not through low code. So there are few other steps like code, low code and no code. This is basically example of code where we'll be doing through coding, and there are low code and no code. Those are very simple, like Na10 and LangGraph. So some flow tools are there where we can just plug and play and can connect to the OpenAI and LLMs and ask questions and get response back. So we'll be seeing those in our future lectures. And the last slide is about me. Uh, Thank you. If you are still here until this slide, I hope you have learned something today, which most of the people probably do not know at this point, how this generative AI works. So now you know how this generative AI works, and much more in details than others. So if you like this video, please subscribe my channel so I can uh, get motivated to create another video for the next topic. Thank you. Have a nice day.